Today we're working with LEDs, and if we're going to work with LEDs and wires, then we're going to need a stripper. So I'd like you to meet my strippers. This one here I've had for a really long time. It's a very simple design. You just set the width there, and then you can pull off most of the sheathing and get exactly the amount you want. And you can also cut it down to size. This one here has a ton more options, a little bit more of a deluxe model. We have ways to cut different gauges of wire. So this is right in there. I go boop, boop, like that. A little nicer. I also have some other options here. I have a little pair of pliers and a way to crimp some of my connectors. This one's a little more exotic. Not only is this a cutter, but it's also got a wire stripper built into the back of it. And it just pops it off like that. Finally, we've got this older model here, still really good, fully automatic. You put it into the right size thing and whoop, it just pops it right off. Lots of options when it comes to strippers. Hey there, fellow maker. Welcome to the shop. Bill here, and today we're continuing work on the Unkempt Herald from Borderlands. Today, we're gonna get the lights working, and I'm gonna show you a couple of other methods for getting LEDs to work in your prop. Why don't we start with a really good example using these super cheap LED flashlights from the hardware store. So these little fellas come in a 2-pack for just $3 at Harbor Freight. And they're not very good LED flashlights, but they are cheap, and there are a lot of components we can pull out of here to use in our projects. I like doing that because then I don't have to monkey with any kind of math. I can just plug these LEDs into the same amount of batteries and I'm good to go. These fellas here have 3 things I like to harvest. One would be all these LEDs. We have to, of course, cut the end of this off to get it taken apart. You could use a bandsaw or a rotary tool to cut it off. And then you can use a soldering iron to loosen up those little LEDs and pull them out of the tiny board in there. Then you've got 9 LEDs that are set to run at 4.5 volts and run off of 3 AA or AAA batteries. You're good to go. The other really cool treat about these fellas is inside the bottom or back side of it here, there is a push button switch. Now it's really cheap and easy to break and maybe not totally reliable, but it is a very low profile toggle on and off switch. I like to use those whenever I can. These also come with a 3 battery holder that fits inside of a cylinder. I'll be honest, I usually don't use these. I prefer the flat ones usually to fit inside of space guns, but if you need a thing that'll hold 3 AAA batteries, this might work for something that's like a staff. If you have a cylindrical tube part of your weapon or prop, wherever you're making, this might fit really well in there. So I keep a couple of these on hand. So these LEDs are all run in parallel, which tells me that each one of these LEDs all by itself can handle the full 4.5 volts. So I know that I can plug these LEDs in by themselves with this. So I'm going to swap it out for this fella right here, just a better form factor for a battery holder. And then once I extract all of these fellas, I can hook them up to my battery. Also, this little switch here is fine, but I have some of my own. This is the type of switch I used in my prop. So I've swapped out the battery and the switch, but I'm going to use these LEDs and I haven't changed any math. Now all I have to do is wire all them together in my prop and I'm good to go. I want to add these wires to my little LED there now. When you buy an LED, it's got 2 different length leads on it, and the long one's the positive one. Of course, with this little fella here, we don't have that option. So I have a diagram that I drew right on my soldering station that shows me which side should be positive and negative. So the next thing I want to do is just wire these wires on it there. I'm going to grab a little bit of solder and my soldering iron, and I'm going to pre-tin the leads, which means I'm just dropping a tiny bit of solder on the bits that are going to get stuck together. Now, since everything has solder on it, I can just touch them together and heat them up, and they stick together. I can do it with both my wires, and that LED is good to go. So this is where we are with the Unkempt Herald. I've wired a bunch of these LEDs with their wires in there, then I have to wire them together into the power source and a switch. So I'll show you what that looks like here on this breadboard, which is super, super useful. I have the batteries plugged in over here, so I can add power to anything along any of these connectors. So if I take my LED and plug it in, like so, it lights up. There's going to be 2 more things. I have more than one LED and I have a switch. So I can just wire more LEDs up to these batteries right in parallel, the way they were when they were originally in their flashlight, and they'll light up no problem. And they all light up the same amount. That's how we're gonna wire everything together, but we want a switch. So this switch is going to bridge the gap between the power and one of these rows here. Then instead of plugging my LED directly into the power, I plug one side into power here, and the other side hooks up to the switch. And now that light won't turn on unless I push the button, just like that. And just like before, I could wire more lights in parallel with this fella, and those will turn them on. So if you were ready to install this in your prop, you could go and solder all these things together just the way they are right now, and you would be all set. But before I do that, I'm gonna dive into some more LED basics, just in case you want to do something a little more custom. All right, here's a quick primer on LEDs and power supplies for those LEDs and switches. Starting with the power supply, I like using normal off-the-shelf batteries. A lot of other people like using LiPos or other battery sources. That's totally cool. I prefer to have everything powered by AA or AAA batteries. That way, if I'm at a convention and I need power, even if I brought a ton of rechargeable batteries, if they're all dead, I could run to the corner store and just buy more AAs. I'm gonna have a hard time buying more LiPo batteries if I'm in a pinch. So that's why I tend to go with those. I buy a lot of different sized battery holders, mostly double and AAA batteries, either 2 or 3 of each of those. So for example, on this project, we're using 3 AAA batteries. So here's my collection, 2 AAs, that would give me 3 volts. So one of these fellas right here. Of course, if you don't have enough room for something like this, you can use these little coin cell batteries. That's also 3 volts. It's just not gonna last as long. So these are a couple of different holders that'll hold these coin cell batteries. There's also smaller, even smaller ones here, depending on your size limitations. For a prop like this, we can fit something this big in there, or even maybe 3 AA batteries. Some of these are really great because they come with a switch right on them. You don't have to worry about it. You can just wire this up to your LEDs and you're good to go. I also recommend a battery checker. This will check any of these batteries, including 9 volts, which is awesome. Sometimes you're putting together a circuit, you don't know why it's not working, and it turns out your batteries were dead. So these things are indispensable. Of course, to hook up your battery to your lights, you need wire. I tend to use just like a 22 gauge wire in red and black for most of the wiring I do. I don't do anything too sophisticated. This is definitely overkill for what I need, but it works and it's easy to work with. The next component is switches. Now, sometimes you don't need a switch, but obviously it's helpful to have one from time to time. Like I showed you before, this toggle on and off button is one of my favorites. You could also use these rocker switches, just a different form factor. They do exactly the same thing. If we hook it up to our little circuit here, you can see that it's on and off and on and off. Good to go. This is almost the same, except it slides back and forth. It does the same thing. It's just, again, a different form factor if you need something to fit into a specific part of a specific prop. So that goes on there, and we can turn it on and off. These two fellas here are momentary. They're not a toggle. So when you plug them in and push the button, they will activate the circuit, but only for as long as you're holding the button down. So this one is normally open, meaning the circuit is open, and when I push it, it is closed and it turns it on. So if you wanted to have a trigger that lit up when you push the trigger, you could use this. This one looks almost the same, but it's normally closed. That means that it is on, or the circuit is closed, when it is not pushed. And when you push the button, it opens the circuit and turns the light off. So this has the opposite effect. This is how Brittany's Sweepy the Robot eyes would blink. She had a button like this near her jaw, and she could poke it with her chin, and it would blink the eyes. These fellas here are normally used as limit switches, so if part of your CNC or 3D printer bumps into it, it pushes the button. One of the cool features about this fella is that it has options for both normally open and normally closed. And if I hook it up to this wire, it will turn on when I push it, but if I hook it up to this wire, it does the opposite. It turns off when I push it. One of the neat things about this fella, though, is I could actually hook up another LED so that when I push the button, the LEDs switch. Now when I push that button, they should switch. And sure enough, they do. Of course, the last and probably the most important component are the LEDs. The important thing you want to look for when you're buying LEDs, or if you already have some, is if on the package it tells you what voltage it wants and what the current is. This one is 20 milliamps for the current. Most LEDs, I should say most off-the-shelf LEDs like this, run at like 20 milliamps. The voltage is different and it changes based on the color. So these here are rated for 3 to 3.2 volts. However, the yellow one I have over there is only rated for 2 volts. That's a pretty staggering difference. If I take 3 volts and run it through a 2-volt LED, it'll light up for a while and it'll be really bright, but then it'll burn out. So you want to make sure that you have the right voltage for the right LED. If you don't, you need to get a resistor in that circuit to keep the LED from burning up. In fact, most circuits are recommended to have some sort of resistance in there just to bump the voltage down a hair below the upper limit, again, so you don't wreck your LEDs. I usually don't put resistors in my circuits for LEDs because they aren't critical. They're not gonna, if one of my LEDs burns up, it's not the end of the world, but I also tend to run a voltage a little bit lower than the LEDs. So these guys are rated for 3 to 3.2 volts. So if I run them on 3 volts off of 2 AA batteries, they should be just fine. You may want to put a resistor in there because it'll make you feel better about how long that LED is gonna last. If so, there's a LED resistance calculator you can use. I'll link that down below. So in practice, you could just buy an LED that'll handle at least 3 volts, buy a 3-volt battery like this little coin cell guy, and when you connect it into a circuit, it'll light up. And you could connect as many on here in parallel as you want, and it should run just fine. So far we've done everything in parallel, and that's usually how I tend to run my electronics, especially just very basic LED stuff. You can totally run stuff in series if that's your jam. I'm not really into that, so there are other resources for you out there. I'll find some and link them down below. The main reason is that parallel is easier. If you chain 2 LEDs together in series, the voltage drops. So you have to either have more battery power or figure out the resistance and all that stuff to get it all to work correctly. The other problem there is if one of those LEDs dies, like your Christmas lights, then the whole string will go out. So that's why I prefer to go parallel. You might have a better solution for yourself, and I recommend you do it the way that works best for you. So here's our example. This is where we are right now in our blaster. As you might have figured out by now, it is super important to figure out where all this wiring is gonna go before you start your build, so that you can plan on where you're gonna run all those wires before everything's put together. Each one of these bundles is 1 LED. This is the switch, these 2 wires. And then these 2 wires are the battery. So I could wire all of these together right in this cavity. I could even reuse this little board from my flashlight if I wanted to. One of these circles, the inner circle, I guess it doesn't matter now, but one of them is positive and one of them is negative. So if I run an LED to here and there, and so on down the circle, then I could wire up 9 LEDs on here. And that would keep everything tidy. I could even run a little breadboard in there if I wanted to. These are mostly used for prototyping though, so I'm probably not gonna do that. Or I could just solder all of the red wires together and all the black wires together. Almost. Let me stick all these pieces together temporarily and I'll show you how it works. Another side note too, if you're doing more prototyping and you're at this stage and a breadboard isn't really gonna fit, these lever nuts are really awesome if you wanna connect a bunch of, let's say, all the red wires. They go in like there, like that, and then I can grab the next red wire and wire all of them together securely, but temporarily. So this fella here is from my battery, and then these are the 2 for my switch. So I'm gonna install one of my lever nuts there to connect the battery to the switch, like so. And then this can now connect to all the rest of these fellas to complete this circuit. So there's our little test, everything's set up, and hopefully when I push this button, the lights turn on. Yeah, they turn on, look at that. So we have a couple in there, we have one in the front, same thing on the other side. Now, again, one of the other reasons I like running parallel is if I need to add more lights to the circuit, so this fella right here isn't attached yet, I could just plug it into the circuit and this will light up as well. No more math, no need to change resistors or anything. The more you add, the higher the current and the more you'll drain your battery. So there is a trade-off. So now it's time to do a little of work putting the rest of the lights in here. Most of the other ones are obviously really simple, just a single LED with a wire coming off of it. We'll wire them all together inside of here, but these side sort of wing things that go on are gonna be a little more complicated, but I have a good plan I think is gonna work. So I'll be honest, I did a little testing off camera just to make sure this was gonna work, but basically I'm gonna punch holes in there to put LEDs in, these little fellas. So this is a template, this is the same template I used to cut this piece of foam out. That can go right in there, and then with a marker, I can just mark where those holes go. Boop. Then just like with a lot of the other holes on our gun, I'm gonna use this leather punch with the biggest setting to punch my holes for those LEDs. There we go. Now these LEDs can go in. I need some to face forward. I'm going to have 4 of them go forward and some to face backwards, and they can just be press fit right in there, and the foam will hold it in place. On this piece, light comes out both the front grill here and on the back of it. So I need LEDs to face in both directions. I have 7 holes, so 4 of them will point forward, these 4, and then the ones I'm putting in right now will face the other direction. I've also drawn a red dot on the positive lead. Since these got trimmed really short, I pulled them out of a flashlight. There's a lead on this side and a lead on this side. I want to make sure the positive ones are all over here so that I can run a wire between them easily, just like that. So all the positive leads are on the right side here, and they're all on the right side here, and I can run a wire between all of them. So the wire is going to come up here and loop through it on the other side. So I want to be able to feed my wire through this foam. So I'll poke a little hole there for one lead and poke another for the other one. Those are all set. I don't even have to glue them. I can just grab my wire and start patching them together. I'm going with a different wire. This is a 28 gauge wire. It's super, super thin. Again, plenty robust for what we're doing. But this is a little different. It does not have a plastic sheath around it. It's got some sort of coating so that it won't conduct electricity unless you scratch that coating away. But I learned that you can just melt it away with solder. That way I can just take this, wrap it around my leads, and then solder them, and you're good to go. You don't have to do any wire stripping. So that's how I'm gonna wire all these guys together. All right, so I'm gonna loop this around one of the negative leads, like that. And you can pull it pretty tight and it'll kind of cinch around there. And then I'll pull it tight, grab my tweezers, wrap it around. And one more on this side. So there's the hole I poked with my awl. I can go through and I can pull it tight. This is almost like a really thin string. You do have to be careful though, you can get it to cinch and then break. So it's gonna go around. Okay, cool. So now I can trim some extra off, and before I do anything else with the other side, with the positive side, I'm gonna go solder all these. If you ever find yourself in the position where the solder will not stick to the tip of your soldering iron like that, that means it's all cruddy. So that's why I have this block of solid sal ammoniac. You can see I have a couple of divots already. What I'll do is press this in there and then feed it a little bit of solder until it sort of chromes up the end of it there, and then it's good to go. Now when I put my solder there, it'll stay on the tip, which is what we want. You can also see I have my fan going. There's an active charcoal filter in there as well, pulling these fumes away from me because this is actually pretty toxic, so you don't want to breathe that in. All right, now we have a fresh tip on our soldering iron. We can solder those leads down. It does take a couple of seconds for this solder to melt through the sheathing, whatever coating is on there. So you do have to be a little patient. This is super, super helpful though, because your wires are all held perfectly in place. So you don't have to clamp them or anything. All right, you can see I've wired up the other side. These are all the positive leads. And again, this is in parallel, not series. And so I'm just wiring one positive lead to the next one. While I'm doing all that soldering, I'm gonna take a moment to thank our patrons. It's because of you that we can work in this wonderful, fantastic, gigantic shop space. We have 2 employees along with me and Britt. And of course, we get to do all these really fun projects. So thank you so much for the support. If you haven't joined already, you can head on over to patreon.com/punishedprops. If you come in at any level, you'll get access to weekly behind the scenes vlogs from the shop. And of course, you'll get all of our build videos early. And as an extra bonus, you'll get an extra credit video for every single one of our build videos. Again, that's patreon.com/punishedprops. Head on over there and consider tossing us a buck and helping us make these wonderful videos. Thank you so much for the support. Let's get back to our lights. Okay, all of our lights should be all wired up. These little wires sticking out though, I'm gonna tin the ends of them. So I'm just gonna put a little bit of solder on them. This will burn away that sheathing and make it easier to connect these temporarily so that we can test them. There we go. There we go. Looks like I got some EVA foam on the tip of my soldering iron there. Oops. I went and soldered some longer wires on there, this thicker wire, partially to make it easier to add it to everything else, but also now I know where the positive and the negative are. Before I do anything else, I'm gonna hot glue that connection right there, because as I monkey with this thing, I'm gonna be pulling on these and I don't want to snap those tiny little wires. So we're gonna ignore all of our other wires for now. We're just testing this circuit and I just have some alligator clips here I'm gonna hook up to the battery. These are the 2 wires for the battery. So the ground or negative wire gets attached like so. And now all I have to do is connect the red wire and hopefully our lights turn on. Yay, all right. That is wonderful. Everything is working. This can be connected with the rest of these guys in parallel and everything should light up. At this point, if one of these guys doesn't work, you want to redo some of the solders. I've found anytime my LEDs aren't working, it's because I usually did a terrible job of soldering. So it might be worth just redoing the solder in there. An unintended consequence, but it's pretty cool. I have 4 of these LEDs facing forward, 3 facing backwards so I can light both sides of this. But the LEDs, the back of them are clear, so I'm actually getting light out of both sides of the LED, and I did not expect that, but that's a great bonus. Boop. So the next thing we need to do is to diffuse these lights. Now in the game reference, there's some sort of grill here, and I think this will be okay. This is some yellow acrylic plastic. There's just a protective piece of paper on there. I have a piece of double-sided tape. There we go. So this is a double-sided tape. I can stick these 2 pieces of plastic together. They'll stay together long enough to cut them both out at the same time. And I can use this same template here. All right, let's take this to the bandsaw. There we go. Then this protective paper can come off. You might be saying, Bill, that's yellow acrylic and it's completely opaque. Well, the good news is light will get through this. It's not so opaque that it blocks all light. It'll actually diffuse it quite a bit, which is nice. To help with that, I'm also gonna sand it with some 220 grit sandpaper. That'll scuff up the surface. And I was gonna use this aluminum tape here, these little thin strips of aluminum tape to make all the grill lines. And I figured that they'll stick better if they have a little bit to grip onto. So opaque plastic, a little bit of sanding, it's about 1/8 of an inch thick, and that should work really well to diffuse all of those LED lights. Might as well sand both sides. One side you're never gonna see, but the more scuffed up it is, the more it will diffuse the light. It scatters the light so it doesn't look like it's got those bright hot spots. These pieces of plastic will eventually live there and in there, but this one, the wires are in the way. You will never see that on the other side. So I think I'm just gonna cut a little notch here on this piece to make it so that our wires have somewhere to go. Let's see, and that fits perfectly. That's how that's gonna go together. But before we glue it in, we're gonna add some grill lines to it. And for that, I have this aluminum tape and I wanna cut it into thin strips. So I have my see-through ruler with a metal edge and a very sharp X-Acto knife. And I'm gonna carefully cut a line. This aluminum tape can tear actually quite easily. So I'm just being really careful, taking a couple passes, and I got a thin strip. I need to make sure that this surface doesn't have any dust on it, because I'm gonna stick this down there, and if there's any dust, that'll keep it from adhering. I have a little bit of isopropyl alcohol. Just gonna use some alcohol and clean off the surface. I like alcohol because it evaporates quickly, so I can make sure the surface is nice and clean, and then blow on it, and it's dry, and I can stick my metal tape on there. And I'm not gonna do anything too crazy, just going to kind of eyeball it. I bet I can make it look pretty okay. I don't think anyone's gonna be here with their calipers judging my work. I can peel the backing off of this stuff and then stick it down to this X-Acto. And then I just wanna make sure it's perpendicular to the straight edge over here and kind of in the middle, and adjust it a little bit. And that's probably good enough. And there's a little bit of overlap, but that's okay. It's fine. No, I don't need it, it's fine. Look I got my human calipers at the ends of my arms. Basically flawless. So again, just peel the backing off, and then I'm gonna leave a gap about the same width as this, but I am just eyeballing it. I could go and be super precise with this, probably. I just don't think it's worth the time. I think that looks pretty all right. So yeah, just do this pretty much forever. It's not, I don't look, those look basically the same distance apart. Okay, I'm putting these on the correct side. I just realized I didn't check if I was putting them on the back or not, but I'm putting it on the right side. Good job, Pass Bill. I've got my grill laid out here. I'm gonna burnish this a little bit, just with a marker. A piece of a metal rod or something would probably work. But I'm basically just pressing it really flat against the surface, really pushing it in there. Hopefully that makes the bond really strong. It also smooths out that aluminum. So if there were any burrs kicked up from cutting it, that should go away, which looks awesome. Then I can flip it over and carefully trim all these little, tiny little bits. And again, I'm using like a sawing motion to hopefully keep it from tearing that aluminum. And that is one pretty great looking grill. Just have to do the same thing over here. Our grills are ready and I'm gonna glue them in place. But first I want to draw a line where I think it ought to go. Just use a pen here for that. I can be a little sloppy with this, but I wanna make sure as little glue as possible seeps out this side of the grill. So let's see if I can do that. Yeah, that's pretty good. This is, I think, ready to go. But first, make sure the lights still work. I always check that my lights work several times because I'm paranoid, especially if you're about to glue a whole bunch of stuff together. There we go. Ooh, oh, that looks really nice. That looks fantastic. If these touch, by the way, that'll short it and turn the lights off. So make sure that doesn't happen. It's gonna look like that. The one thing I'm noticing, it looks really good, but there's a little bit of white light leaking out up there. I don't know if you can see that. There's just a little bit of light there and a little bit down here. So I think I need to block just a little bit of the back of this right here. So I'll just glue a chunk of foam on there, like so. Now that I have my light leak guards, I can put this on there. There we go, awesome. I only see the yellow light coming out, no white light. So that's what we want. And this is great news because I think all of our LEDs are wired. We just need to connect them all and then glue it all together. I am organizing all the wires that are already in here into red and black groups. Since I'm wiring these all in parallel, all of the LED wires that are black need to get connected. And same thing with red. Gather up all the black wires just to tidy them up. Let's zip tie those together. And same thing with the red wires. Everyone in. I can also install one of the side panels. I don't think I need to glue them in. I'm just gonna kind of pressure fit them in there. That way I could clob them out and work on these wires if I ever have to. I don't predict that I will, but at least I have that option. So this guy's going in. And this is when I can finally cut some of these leads a little shorter than they need to be, now that I know what their final length probably ought to be. We're getting there, making some progress. I'm going to cut each of these bundles of wires down to the same length and strip the ends of them so that I can twist them all together. We're trying to get to a point where I can test all of the lights at the same time. So those are all the same length and I can sort of twist them together or mash them in the end of a lever nut. Just like that. Now those are all in there and I can connect them to whatever I want to test. Do the same thing with all the red ones. I'm making lots of progress, but I'm trying to think really hard about when I should do each step. And I think the next step I'm gonna have to do is to glue this wing thing on this side. I pulled this guy out, it was backwards. But I think I need to have this open to feed a wire through there. So glue this on with some barge and then I can tuck this back in. Here we go, let's stick this down forever. Just kind of double checking that everything is in pretty much the right spot. And great, so this wire for those lights can get tucked in there. Then this one, if I make it face the correct way, can go in. And then we can add these wires. Now this is an example of some leads I should have left a little longer. They're kind of hard to get at there. I decided to make those longer. Okay. These bundles I wired all together so I can add them to the circuit, like so. These two parts will be the last pieces I attach once everything's soldered together, but now I just want to test them before it's all put together while I still have a chance to fix anything in case it's broken. These are from the battery here. So one of them I'm going to attach to the switch. These two wires are the switch. They'll stay together. And then this red wire needs to go into there. And I'm a little short. I'll just grab a little wire to use as a jumper. I'll put this fella in there. And then I'll just connect it. I think I've done everything correctly. If I have, when I push this button, all the lights will turn on. Here we go. Is that all of them? Yes! All the lights turned on. That's great. Pew, pew, pew. That was the last test. I can take these bits off, and then all of these temporary connections that I made with my lever nuts, I can make permanent. All of the negative leads have been bound together in this bundle here. I'm sure there's a better way to connect this many wires. I just don't know it. So I'm just going to carefully solder this whole thing together until I'm confident that none of these will fall out. I feel like those are all pretty secure in there. I can trim this a little bit. And then I'm gonna put a big piece of heat shrink tubing around this. Not big enough. Yes. So that's just gonna cover as much of that as possible. It looks like I'm good. And then a lighter or a heat gun on the heat shrink tubing, or you can just use the soldering iron to get it to shrink up a little bit. I'm worried about getting in here with a heat gun and wrecking all this foam. So I'm just kissing it with the end of my soldering iron here. There we go. That'll keep all these black wires from shorting with the red wires. And now I can do the same thing with those red wires. I think I'm ready to put these last bits here and just stuff all my wires together. I actually cut a corner out of each one of these in this area where you're not going to see it so that it has room for the wires from this guy to get down in there. I'm going to glue one side of this in, and I think I want to glue this side. So I'm just going to put a little hot glue on there. That. And then this one, I think is just going to be friction fit in there. So it doesn't want to fall out or anything. But if I do have to get at those wires, I still can, just by prying that out. We're just about ready to move on to painting, except for one important factor. Our lights are yellow here and white here. We want them all to be yellow. So I think what I'm going to do is just try and paint all of these LEDs with a yellow acrylic paint. There are all of the lights on our Unkempt Herald from Borderlands, and I'm pretty excited about how they're turning out. Especially excited about the grill here. That looks like it jumped right out of the video game. Pretty stoked about that. I hope you learned a thing or two. Like I said, I'm not really an electronics expert, and I try and run things as simply as possible. That's what I've done here, and it's worked for me for the past 10 years or so, so I'm probably gonna keep doing it. You probably have your own way you like doing wiring, so if you want to leave any tips or suggestions, please do so in the comments. If you're super new to this and you have questions, you can leave those in the comments as well. As always, all of the tools and materials that I used for this will be linked down below. And I want to thank again our patrons for supporting us and helping us work in this wonderful, awesome, gigantic shop and do really fun projects like this. You can head on over to patreon.com/punishedprops to join in on the fun, get access to behind the scenes vlogs, our build videos early, and of course, our extra credit videos, which I will be doing one for the lighting on this. So if you're a patron, you can go over there and check that out right now. That wraps it up for today. Next time we will be painting and finishing this beast, so be sure to tune in for that. If you haven't subscribed already, go ahead and hit that button. And that'll do it, I guess. Time to get to painting. I'll see you next week when we jump in and get our hands dirty.